Can we predict when the Earth will shake beneath our feet, heralding the arrival of an earthquake? This is an age-old question that has puzzled scientists and seismologists across the globe for centuries. Predicting earthquakes with any degree of accuracy is a challenge that has remained largely unsolved. The unpredictability of these seismic events, their devastating impact, and our continued vulnerability to them make this a question of paramount importance. Earthquakes, by their very nature, are complex phenomena that occur deep within the Earth's crust. They are the result of tectonic forces, building up energy over time until the Earth's crust can no longer withstand the pressure. Then, in a matter of seconds, that energy is released, causing the ground to shake and often resulting in widespread destruction. Scientists have been trying to crack the code of these enigmatic events for years. They've studied patterns, analyzed geological formations, and even tracked animal behavior in hopes of finding a reliable prediction method. But despite these efforts, we still don't have a foolproof system for predicting earthquakes. The current methods can provide a general idea of where earthquakes are likely to occur, but they can't tell us exactly when. Why is this prediction so important? Well, imagine the difference it could make. With accurate predictions, we could have efficient early warning systems. People could be evacuated from danger zones, buildings could be reinforced, and emergency services could be prepared. The potential to save lives and minimize destruction is immense. But despite our best efforts, this goal has remained elusive. The complexity of seismic activity, coupled with the vast amount of data to be analyzed, makes it a colossal task. The traditional methods of seismic data analysis, while valuable, have their limitations. But what if the solution lies not in the traditional methods we've been using, but in the realm of artificial intelligence? As we delve into the 21st century, the potential of AI and machine learning in predicting earthquakes is being explored with promising results. But that's a discussion for our next scene. Until then, keep pondering on the power of AI and the difference it could make in predicting when the Earth will shake. Before we dive into how AI can predict earthquakes, let's clarify what AI and machine learning are. Artificial intelligence, or AI, is a technological marvel that enables machines to mimic human intelligence. But what does that mean? Well, think of it this way. Imagine you're playing a game of chess with a computer. The computer isn't merely responding with pre-programmed moves. It's analyzing the board, considering all the possible scenarios, and making strategic decisions, just like a human would. That's AI at work. But what about machine learning? Well, machine learning, or ML, is a subset of AI. It's like a student who learns from a textbook. The student reads the information, understands it, and applies it to solve problems or answer questions in the future. Similarly, in machine learning, machines learn from data without being explicitly programmed. To illustrate this, consider a music recommendation app. When you first use the app, it might suggest a wide variety of songs, but as you listen more and more, you start to skip some songs and play others on repeat. The app picks up on these patterns. It's learning your preferences. Over time, the app's suggestions become increasingly tailored to your taste. That's machine learning in action. So, in essence, artificial intelligence is like a computer playing chess, analyzing and making decisions. And machine learning is like a music app, learning your preferences and tailoring its recommendations accordingly. These technologies have far-reaching applications beyond games and music, though. They're used in everything from self-driving cars to healthcare, and yes, even in predicting earthquakes. Now that we have a basic understanding of AI and machine learning, let's explore how these technologies can help us predict earthquakes. Imagine a machine that can analyze billions of data points from seismic activities and learn to predict earthquakes. This isn't a plot from a science fiction novel. It's a reality we are living in today, thanks to artificial intelligence. Artificial intelligence, or AI as it's commonly known, has been making waves in various fields, and one area where it's making a significant impact is in seismic data analysis. Machine learning, a branch of AI, offers an innovative approach to handle and interpret vast amounts of seismic data. Seismic data is complex and high-dimensional. It's akin to a jigsaw puzzle with billions of pieces, each piece representing a data point originating from the Earth's seismic activities. Traditional methods of analyzing this data often fall short due to the sheer volume and complexity of the information. Enter machine learning. Machine learning algorithms can process this data, learning from each data point and building a model that can detect patterns and trends that might be invisible to the human eye. The more data the algorithm processes, the more it learns, and the more accurate its predictions become. So what makes machine learning superior in handling seismic data? First, it's the capability to process data on a scale that's beyond human capacity. Second, machine learning algorithms can handle the high-dimensional nature of seismic data which traditional methods struggle with. But perhaps the most significant advantage is the ability of machine learning to learn from the data. It's not just about processing information, it's about understanding it and making predictions based on that understanding. The algorithm becomes better with each data point it processes, continually improving its predictive capabilities. This process is like teaching a child to recognize shapes. At first, the child might struggle to distinguish a square from a rectangle, but with more exposure and learning, the child becomes proficient at recognizing different shapes. Similarly, the machine learning algorithm becomes more adept at predicting seismic activities with more data. The potential of machine learning in this field is immense. But how exactly does it predict an earthquake? Well, that's a topic for our next scene, so stay tuned. The key to machine learning's power in earthquake prediction is in its ability to identify patterns in data that humans can't. Now, you might be wondering, how can a machine do what a human can't? Well, let's dive a bit deeper. When we talk about machine learning, we're referring to a type of artificial intelligence that can learn and improve from experience. It's like training a dog, but instead of teaching it to sit or fetch, we're teaching our machine to analyze data, lots and lots of it. In our case, this data is seismic activity recorded over many years across the globe. Now imagine trying to analyze all this data manually. It would be like trying to find a needle in a haystack, right? Machine learning models, however, can ingest and process this data much faster than any human could. Moreover, these models can recognize complex patterns and correlations that might be too subtle or too intricate for a human analyst to spot. Take, for instance, the relationship between seismic activity and other geological factors. A machine learning model can analyze these variables together, identifying patterns that might suggest an impending earthquake. It's like a detective piecing together different clues to solve a mystery. But it's not just about pattern recognition. Machine learning models can also learn from past seismic events. They can identify what conditions led to past earthquakes and use this knowledge to predict future seismic events. It's like having a history book that also tells you what's likely to happen in the future. Of course, it's important to remember that machine learning isn't infallible. It can't predict earthquakes with 100% accuracy. There are still many unknowns in the complex world of seismology. But what it does offer is a significant improvement in our ability to forecast these natural disasters. While it's not a crystal ball, machine learning gives us a powerful tool to better predict and prepare for earthquakes. It's a giant leap forward in our ongoing quest to understand and safeguard against the unpredictable forces of nature. The application of AI and machine learning in earthquake prediction marks a significant shift in how we approach this age-old problem. These technologies are not simply tools, but potential game changers that could revolutionize our understanding of seismic activities and our response to them. In the realm of earthquake prediction, every second counts. The potential for AI and machine learning to improve early warning systems is immense. Imagine if we could provide communities with even just a few more seconds of advance warning. That additional time could mean the difference between safety and catastrophe. It could allow for the immediate shutdown of vital infrastructure, the halting of trains, and the grounding of flights, thereby preventing further disaster. But the benefits of AI and machine learning go beyond just early warning systems. These technologies could also significantly enhance disaster management strategies. By accurately predicting the impact and extent of an earthquake, we could better prepare and mobilize resources, potentially saving countless lives and significantly reducing damage. Ongoing research in this field is promising. Scientists are continually refining machine learning models, using complex algorithms to analyze vast amounts of seismic data. However, there are challenges. Seismic events are incredibly complex phenomena, and the data is often noisy and incomplete. Furthermore, these machine learning models require substantial computational resources. There is also an urgent need for more data. Every earthquake offers a unique opportunity to learn more about these seismic events. The more data we can gather and feed into these models, the more accurate our predictions could become. While we may not have the perfect solution yet, the fusion of technology and seismology brings us one step closer to predicting the unpredictable. The future of earthquake prediction is bright, and with continued research and development, we may soon be able to give communities the warning they need to brace for impact and ultimately save lives.